Lesson 2. Measuring correlation. You can calculate quantitative values to measure the strength and type of linear correlation between two variables. One of these is called the product moment correlation coefficient, denoted by the letter R, which you can automatically find on your calculator. It describes the linear correlation between two variables, taking any value from -1 to 1. If R is equal to 1, then there is a perfect positive linear correlation. If R is equal to -1, then there's a perfect negative linear correlation. The closer R is to -1 or 1, the stronger the negative or positive correlation, respectively. If R is 0 or close to 0, then there is no linear correlation. There might still be a non-linear relationship between the two variables, though. R measures the strength of the correlation. It doesn't tell you anything about the gradient or the y-intercept, about the regression line. Let's do one example. The data in the table is from the large data set for the first 10 days in September in Hearn in 1987. It shows the daily mean wind speed in W knots and the daily maximum gust in G knots. Part A. State the meaning of NA in the table above. Part B. For the remaining 8 days, calculate the product moment correlation coefficient. And then Part C. Referring to the answer of Part B, comment on the suitability of a linear regression model for these data. For Part A, we can just say that the data on the daily maximum gust is not available for these dates, as it says NA. For Part B, if we enter the data for the remaining 8 days on our calculator, on the statistics part for the y equals a plus bx line, then we can go to the regression calc, and we see that R has a value of 0.953297, or we can write R is equal to 0.953324 dp. And then for Part C, we can say that R is close to 1, so there is a strong positive correlation between the daily mean wind speed and the daily maximum gust. This would then mean that the data points would lie close to a straight line, so a linear regression model is suitable. And that's about it.